So, dear students, welcome back to the series of video lectures on the topic voltage flicker. So, as we have discussed the voltage flicker in previous video also, but giving some kind of the brief description, what is a flicker? So, the power line flicker is a visible change in the brightness of a lamp due to rapid fluctuations in the voltage of the power supply. So these flickers do affect sensitive electronic equipment such as the television receivers or the variable frequency drives, AC/DC drives, etc. So the sources are like steel mill, electrical motors, arc furnace, elevators, intermittent loads. So in case of the industrial loads, the main sources are industrial loads for the voltage flickers are arc furnace, welding machines, electric boilers, capacitor banks, electrical appliances supplied from the low voltage networks, wind turbine generation system. So let us see the arc furnace. So the arc furnaces can range from a few MVA to more than 100 MVA, and they are one of the major sources of the perturbations connected to the HV network from the point of view of flicker arc furnaces. Next is the welding machines. In a welding operations, short intervals of the welding are followed by others of no load operation with a high current flow. In each welding operation, two voltage steps are produced, one at the time of establishing current and another at the instant of the disconnection. These voltage variations can cause the problem in nearby loads, producing voltage magnitudes outside the voltage tolerance limit and can even produce a flicker. Electric boilers are used in industrial applications for generation system, generating steam. Thus, the required control of the temperature together with the varying need of the steam lead to periods of the high power demand followed by the periods without energy consumption. That leads to the voltage flicker. Capacitor bank. Switching on and off of a capacitor bank produces the voltage step proportional to the reactive power capacity of the capacitor bank and inversely proportional to the short circuit capacity of the point of connection. In general, the most common power quality problems related to the capacitor bank are the appearance of resonance phenomenon between the capacitor and inductive element of the system and the possible overvoltage transient due to the capacitor's connection. It is only in very rare cases that voltage variations caused by the capacitor switching can lead to the noticeable flicker level. In recent years, power systems have experienced a significant increase in the wind energy penetration. Wind turbine generates the fluctuating power during the continuous operation that can lead to the voltage fluctuation at the point of common coupling. In this regard, variable speed turbines have some advantages concerning flicker emission. In addition to the continuous operation, switching operation of a wind turbine are also potential cause of the voltage variation, as these are the intermittent source of the energy. So what are the mitigation techniques basically? In general, there are 4 mitigation techniques used for the voltage sag mitigation. There is a flicker mitigation, increase system capacity, motor modification, series capacitors, and starting of load in step by step. So flicker is caused by the voltage fluctuation, therefore any strategy oriented to mitigate the flicker must be based on reduction of the voltage fluctuation. That is the principle of operation. So two kinds of the approaches can be applied for this purpose. Decreasing the power variation, mainly reactive power variation of the load. For that purpose, we'll use SVC, that is static overcompensator, then insertion of a saturable inductance, insertion of a series inductance. Second is increasing the short circuit power level, connection to the network at a higher voltage level, or parallel connection of the mains transformer. So these are the certain ways to mitigate the issues related to the voltage flicker. So thank you for your patient listening.